In this video, I'm going to take you through how to calculate the equivalent weight of a given compound, either being a base, a salt, acid, and any given compound, how to calculate the equivalent weight of any given compound. So equivalent weight is a mass of a substance that will combine with or displace 1 mole of hydrogen ion in an acid-base reaction or 1 mole of electrons in a redox reaction. We'll look at what exactly this means in the later part of this video. So let's start with bases. Equivalent weight equal the molecular mass of the compound all out of n factor of the compound. So for bases, so to find the equivalent weight, what we need to do is to find the molecular mass of the given compound and the n factor. Then we can then go ahead. So let's find the equivalent weight of NaCl. So for bases, NaOH. So for bases, what we do is, when it comes to the n factor, we look at the number of OH ions that are present, or the number of OH ions that the base can supply per molecule. So looking at NaOH, let's look at our OH part here. You see that this is actually equal to 1, right? OH, we only have only one OH. So this to tell us that our n factor equal 1. And the molecular weight or molecular mass of sodium hydroxide, sodium is 23 and oxygen plus 16 and hydrogen plus 1. So this will be giving us 40, right? So we can go ahead and calculate for equivalent weight of sodium. Should be sodium hydroxide should be equal to the molecular mass over n factor, which is 40 on 1, which is the same as 40 in grams. Equivalent weight for KOH. First of all, we look at the n factor, and this is a base. The n factor will come from the number of OH ions that the base can supply per molecule. So looking at this, we have only one OH ion. So our n factor equal 1. And molecular mass for KOH is going to give us 56. So our equivalent weight for KOH equal to 56 all on 1, which is going to give us 56 grams. Number 3, to find the equivalent weight of MgOH2. So this is a base. The n factor will be the number of OH group that the compound can donate. So here we have 2 OH. So our n factor right here equal 2, right? So molecular mass for MgOH is going to give us 58. So molecular mass of MgOH is OH2 is 58 gram per mole. So our equivalent weight here is going to give us 58 molecular mass all on n factor, which is 2, and this is going to give us 29 grams. Equivalent weight for BaOH2. So first of all, our n factor will be coming from here, the number of OH ions that we have, which is 2. So let's say which is 2. And molecular mass for BaOH is 171. So 171. So this will be giving us 85.5 grams. So that is the equivalent weight for BaOH2. So equivalent weight for AlOH3. So from here we could see that the number of OH group that we have here is 3, right? So directly N factor is 3, and the molecular weight for ALOH is 78. So 78 divided by 3, this is going to give us 26 grams. What about for NH3 compound? What we do is that we add we add water. To find the equivalent weight of NH3, we add water. So NH3 plus H2O. So this will be giving us NH4OH. So now we want to we are finding the equivalent of NH3. For only NH3, you have to do it this way, right? Or if you just know the equivalent weight of it, then you are good to go. So now, but we are going to use the molecular mass of NH3, not NH4OH, right? So now, but our N factor will come from the product here, which is the number of OH ion available, right? That this can donate. So here we have our N factor to be equal to 1, right? But we are going to base on the molecular mass of NH3. So NH3, we have molecular mass of NH3 to be 17, right? So our equivalent weight is going to give us the molecular mass all on the N factor, which is 1, right? Which is going to give us 17 grams. Now, equivalent weight of acids. For acids, we are going to look at the basicity of the acid. The number of ionizable hydrogen ions per molecule. Yeah, so our N factor is going to come from the H plus ion. So find the equivalent weight of HCl. So for HCl, you know that we can break this down into H plus plus Cl, right? So the number of the number of H plus ion will give us our N factor. So we have only one H plus ion here. So our N factor equal 1, right? And the molecular weight for HCl, hydrogen is 1 plus chlorine is 35.5. So 35.5. So this is going to give us 36.5, right? So equivalent weight equal the molecular mass, which is 36.5, all on N factor, which is 1. So this is going to give us the same 36.5 grams. So find the equivalent weight of HNO3. So we break this into H plus NO3 minus. So we have only one H plus here, so our N factor is 1. So what's the molecular mass of HNO3? I've calculated all this here. So this is 63. So equivalent weight of HNO3 equals the molecular mass, which is 63, all in the N factor, which is the available H plus ion, that is 1. This is going to give us 63 grams. Equivalent weight for H2SO4. So you know that sometimes we can just look at the compound and know what to do, right? You can see that we have two of H, hydrogen here. So definitely we are going to get 2H plus, which is telling us that our H plus ion is going to be 2, right? So our N factor is 2. So we have H plus plus SO4. So to balance this equation, we have to add 2 here, right? So you see we have 2 of the H plus ions. So our N factor, which is N factor equal 2. So molecular weight of H2SO4 is 98. So our equivalent weight equal 98 on our N factor, which is 2. So this will be giving us 49, right? 9 grams. So find the equivalent weight of CH₃COOH. This compound, when it breaks, it's going to break, start somewhere here. So it means we are going to get our CH₃COO ionized into C plus H plus ion, right? So is there anything here that we need to balance? I think no, we have 3 of the hydrogens, 4 of the hydrogens here, and 4 of them here, 2 carbons. So everything is okay. So this is our N factor equal 1. The H plus ion, we have 1 of them. So our N factor is 1. Molecular weight of this compound right here is 60, right? So our equivalent weight is going to be 60 out of 1, which is the same as 60 grams. What about H₃PO₄ HCO3. This will decompose or ionize this into H plus H₃PO₄. So we can definitely see our N factor here to be 1. So molecular mass for H₃PO₄ is 62. So our equivalent weight equal the molecular mass, which is 62, all on the N factor, which is 1. So this is going to give us 62 grams. Then again, some of the molecule, before you add, you find the equivalent, we have to do something before going ahead to calculate for the equivalent weight. So let's say for SO2 and SO3, we are going to add water, right? H2O, before we can find the equivalent weight for them. So let's say we are to find the equivalent weight of SO2. What we do is we add water. So this will give us H2SO4. And then for SO3, we also add water. This will give us H2SO4. Sorry, falsely. So in all, we know that the N factor right here is 2. Why? This is an acid, right? So the N factor will be coming from the number of hydrogen ions that the compound can donate, right? Per molecule. So our N factor here is 2. So all we have to do is to calculate for the molecular weight of this, molecular weight of that. So molecular weight for SO2 is 64, right? So for equivalent weight of SO2, is going to the molecular weight, which is 64, or on the N factor, which is 2. And then equivalent weight for SO3, molecular weight for SO3 is 80. So this is 80 on the N factor, which is 2. So this is going to give us 3 here, 2 grams. And this is going to give us 40 grams. So these are the equivalent weight of SO2 and SO4. So once we are okay with this, just familiarize yourself with all this and you'll be fine. So what about phosphorus compounds? How do we find the equivalent weight of phosphorus compound? For this, the N factor is the total number of oxygen minus 1. So we want to calculate for the equivalent weight of H₃PO₄, right? And here we also have PO₃. So all we have to do is to know the molecular mass of this, molecular mass of that, and then the N factor. And we said for phosphorus compounds, the N factor is the number of oxygen minus 1. So how many oxygen do we have here? We have 4. So for our N factor, we equal to 4 minus 1, which is 3. How many oxygens do we have here? We have 3, right? So our N factor equals 3 minus 1, which equals to 2. So this is the general idea that really works. So once you are okay with this procedure, you'll be good to find any equivalent weight given. Problem given to you. So now the molecular weight of this, calculated it already, is 98. So equivalent weight of H₃PO₄ equal the molecular weight, which is 98 over N factor, which is 3 right here. So and the equivalent weight for H₃PO₄ is, the molecular weight of H₃PO₄, which is 82 over the N factor, which is 2. So this is going to give us 41 grams. And here we are going to get 32.667 grams. So now equivalent weight of salt. For equivalent weight of salt, what we do is our N factor is going to come from the total charge on cation. So NaCl can give us plus. So our cation here is the Na plus, right? So we have only one of them. So meaning that our N factor here equal 1. And the molecular weight for NaCl is 58.5. So our equivalent weight equals molecular weight for NaCl, which is 58.5, all on N factor, which is 1. So this is going to give us 58.5 grams. So what about CuSO4? So this is going to give us Cu2 plus SO4 2 minus. So from the previous example, we said our N factor is from the charge of the cation. The charge on the cation. So we have 1 here. That's why our n factor was 1. So here the charge on the cation is 2, right? So 2 plus. So our n factor here is 2. And the molecular weight for copper sulfate is 160 gram per mole. So equivalent weight now equal to molecular weight of CuSO4, which is 160 all on n factor, which is 2. So this is going to give us 80 grams. So for K2SO4, we see that we have K plus SO4, 2 minus. So let's balance the equation. Doing this, we have to make sure that the equation is balanced before you figure out your n factor. So we have 2 of K here. Let's put 2 here, right? So this 2 is definitely going to be affect the charge, which is plus 2, right? So it's definitely going to affect the charge. So we have our n factor here to be 2. Assuming we have 3 here, then our n factor is going to be 3. 4 here, going to be 4. So now molecular weight for K2SO4 is 174. So our equivalent weight equal 174 all on an n factor, which is 2. So this is going to give us 87 grams. Find the equivalent of MgCO3. So this is going to ionize into, right? So we have 2 of the charge on the Mg is 2, right? So our n factor is 2. So our n factor here is 2. Molecular weight for MgCO3 is 84. So 84 grams per mole. So our equivalent weight for MgCO3 equal the molecular mass, which is 84 grams per mole, all on 2, which is the n factor. This is going to give us 42 grams. Equivalent weight for Al2 into bracket SO4 3. So this will ionize into, we have Al 3 plus SO4 2 minus. Is this equation balanced? No, the equation is not balanced. So here we have 2 of the Al, we have 1 of the Al here. So we just have to put 2 here. So now what is our n factor going to be? Our n factor, this will affect our n factor. So we are going to multiply this by the charge on the cation, so which is 6. So our n factor here is actually 6. So the molecular weight of Al2SO4 3 is 342. So molecular weight is 342 grams per mole, right? So equivalent weight is going to be 342 all on the n factor, which is 6 right here. So this is going to give us 57 grams. What about this? What is the equivalent of CaCO3? This is ionized to this plus CO3 2 minus. So here, what is our n factor? Since the equation is balanced, our n factor is directly the charge on the cation, which is 2. Molecular weight for CaCO3 is 100. So 100 grams per mole. So our equivalent weight is going to be 100 divided by 2, which is 50 grams. So what about Al2O3? This is going to be ionized into plus O 2 minus 3 plus, yeah, it changes their valences. So here we have 2 of the Al here, so we just have to put 2 here. So in this case, our n factor is 2 by 3, which is 6. N factor is 6. And the molecular weight of Al2O3 is 102. So our equivalent weight is going to be the molecular weight of Al2O3, which is 102 divided by the n factor, which is 6. So this is going to give us 17 grams. So what exactly does this mean, and how useful is this to us? So in neutralization reaction, where we have an acid or an acid reacting with a base to give us a salt and water. So let's balance this equation. I think there should be 2 here. Let's see how useful equivalent weight is. I want an exact weight of this, my sulfuric acid, that will react with the sodium hydroxide directly, completely to give me a result in which maybe let's say I won't get any waste of reagents, I won't waste my reagents. So I want to know exact sulfuric acid that will react completely with sodium hydroxide, right? So what we do is, and I know that this is a base and this is an acid. For equivalent weight of acid, the N factor is going to be based on the number of H plus ion that the acid can donate, right? And for bases, the N factor is going to be a number of OH that the base can donate, right? So from the looking at the acid here, I could see that the N factor, you could see that the N factor equal 2, right? And for the base, the OH ion, forgetting about this, let's see here. You see that the N factor equal 1. The molar mass of H2SO4 is 98 grams per mole, and that of the NaOH is 40 grams per mole, right? So equivalent weight of sulfuric acid equal to 98 grams per mole, all on the N factor here, which will give me, which will give us 49 grams. And that of the sodium hydroxide is going to be 40 on 1, which is going to give us 40 grams. So what this is telling me in this reaction is that 49 grams of sulfuric acid is going to react completely with sodium hydroxide. So I should get 49 grams of sulfuric acid and then 40 grams of sodium hydroxide before they can react completely without any waste. So this is 1 mole of sulfuric acid. We need 49 grams, and 1 mole of sodium hydroxide, we need 40 grams to react completely. But now we have 2 moles of sodium hydroxide here. So this is telling us that, so to make them equivalent, because we have 2 moles here, so we know that a mole of, H2SO4 is 2 equivalent, right? And we have, let me write this thing down. A mole of H2SO4 equal to 2 equivalent. And then how can we get 2 equivalent? 2 equivalent of H2SO4. How do we get 2 equivalent of sodium hydroxide? We need 2 moles, right, of sodium hydroxide to give us 2 equivalent of sodium hydroxide, right? Before they can be equal. So all I'm saying is that this mass here means a mole of sulfuric acid reacting with a mole of sodium hydroxide. These are the masses that we need them to react completely. So in this case, we have 2 moles of sodium hydroxide. So this mass should be multiplied by 2, right? So which is going to give us, for 49 grams of sulfuric acid, we need 2 by 40 grams, which is 80 grams of sodium hydroxide to react completely. So that is what you should know. You see, it's very helpful. So thank you for watching my video. If you found this helpful, kindly hit the like button, subscribe, and also recommend my videos to your friends.